We're live. I just want to make sure. Yeah, that clicking you can hear. Okay, perfect. I can hear the music, but you can't. If you want to listen, this is what I'm listening to right now. So I've got this like project. Oh, frick. Let me get a better. I have wanted to build this for a long time, and it doesn't look like much, but what I have here is 2 relays. I actually got these out of the free parts bin at work when I was an intern like 12 years ago. I've been calling them around all this time, and they're sweet. They're good relays. They're 5-volt little tiny relays. Just got a super simple flyback diode there. Got to have a flyback diode if you're driving a coil. If it doesn't have one built in, because it builds up energy and it'll send it back through the negative line when that coil collapses, and that can kill your input. So you got to have a diode there. Super simple. And I just loaded up an Arduino sketch here. This is actually a Catskill Electronics original product that I sold I think none of. I have like 500 of these. They're little Arduino Nanos with a USB-C port, just super simple AVR Atmega 328P on there. And these sick WCH USB serial chips that I became a big fan of. Anyways, I just wrote some Arduino code. This is sending Morse code out. It's just a little message. I was playing around with different like rhythms and beats, and dude, the mechanical sound of that switch, it's just, you can't beat it. I mean, I don't know what it is. Actually, let me pull up here's what I like to do. I like to do it on my phone. I don't know, like, and even I was like driving them like super fast, like toggling them on and off, like every millisecond. I don't know how many times that is, but like it sounded like death. I mean, it sounded scary. Wow. I mean, that's I don't know. I'm just imagining like a scenario where somebody uploads like malicious firmware to something with a relay in it and just like starts, pulsating at that, because it'll wear it out. Like, and depending on that relay drives, like you could cause catastrophic failure. If you have, I don't know, something on there. I actually had a catastrophic failure in my office yesterday. Let me see. I got to pull up the stream. I had an FTDI USB adapter that I was using for 5 volts to power something. And I just had the wire headers like sticking out, and I guess they were bridged together. And I was sitting here and I was like, man, what is burning? Like that distinctive smell of burning plastic, right? Like, uh-oh. Like, and I was convincing myself it's just because the heater was turning on. It's like sometimes, when the heater kicks on, we don't run it that often. So maybe it just like smell weird. But then finally I like looked down, it was like super hot. And like the crazy thing is it was plugged into my MacBook with like a USB-C port, and like that port is completely fine as far as I know, knock on wood. Like I was testing it out. So, and the USB cord was pretty warm, but like the wires on the FTDI were literally fried. I'm going to actually pull up a picture of it. Yeah. You see that? I need to do a projector preview here. Let's see. Still working on pulling up the stream. Music is hitting hard though. All right, here we go. All right. I'm getting distracted. All right. All right. Anyways, so yeah, I guess moral of the story is don't leave power cords laying around. Although I literally had like a suicide cord, quote unquote, which is a cord that is an AC power cord with the end cut off of it with just exposed wires on the end of it, meaning like it's potentially lethal. I had one of those like laying on the floor of my shop, like plugged in for months. Then one day I was like, what is this? What is this plugged into? And I was like, pulled the cord. You know how you do that? You're like, woo, woo, woo. It's just like AC wires, like the green and the white wire and the black one. You're like, oh, frick. Unplug that bad boy pretty freaking quick, I can tell you that much. Let's see. I'm going to send this to my friend Pachaki. All right. So the idea is then, you hear that? You hear that nice clickety clack? I want to make a clock, a 4 digit clock, 7 segment, 4x7 segment digit clock. And I want each segment to be driven by a relay that turns on manually like that because I think it would sound sick. Dude, and like if all the digits changed, like if every segment changed, it would be like, and I'd probably program some like a very slight delay so it's not all just like, it would be like, because, okay, the motivation here is that there's a display technology called split flap displays, if you're not familiar with this. This is like how to be a hipster 101. Okay. Hipster lessons. They're currently, I don't believe it. They're freaking expensive. Yeah, this Oat Foundry place, supposedly they make a really good one, but if I remember right, it's like 10 grand. They don't even put the picture, you request a quote, you can't afford it. They're so expensive. And there's cool ones like they used to, they pull them out of airports, train stations. They're very cool. We had a clock growing up that had a split flap display on it, and it was very cool. The issue is that one, they're extremely expensive. They're no longer made. Very complicated mechanical display mechanism. Man, I wish I still had that clock. I know exactly what it looks like. I wonder what it was. My dad's too. It was like baby blue, light blue, with a radio in it. That thing was sick. They're just super expensive, and like honestly, realistically, they're loud. Like they're freaking loud. So a little too loud for me. Also unobtainable. And I don't know, relays sound very nice. Like, you ever listen to your car blinker when you your turn signal? That's a relay. Yeah, I just think it'd be cool. Like, and especially if I design it so that the relays are arranged in such a way that they look neat and organized, I think it would look very cool. Like, yeah, I don't know, relays. I don't know. For some reason, I guess I've always felt like blinking an LED is so much more fun than Hello World on a screen. I don't know. I don't know why, but I think there's like this bridge from the digital to the physical world. Like obviously there's some physical stimuli of printing text on a screen and the light hitting your eyes so you can comprehend it, but seeing an LED light up, like from a program you wrote is just like, and I know I've taught, you talk to people and this is very common. Like it hits different. Okay. And I think that any time that you're able to interact with the sensory world like that, be it via light or sound or, tactile feedback, sensory feedback, visual feedback, I don't know, man. It just adds another dimension to the technology that makes it, I don't know, it just makes it more present, I guess, in your life, right? I've got a buddy who is studying, I don't even know, man, like optics, like shooting little lasers directly into your retinas to create like heads up display. And I don't know, this philosophy I think reaches throughout a lot of how I view technology. Like, I'm big on input and output for computers and technical devices, right? Like, I have no interest in running a 486, Intel DOS box or whatever, right? Like, I can emulate that functionally just as well, but you can't emulate the sound of a ticking hard drive or the CMOS beep or the hum of a cathode ray tube. Even the fans, like booting up an old computer felt like it was a relic. And that I think is more what I'm chasing. I'm not, the experiences we have within the computers themselves, I think can be pretty replicated, but the experiences we have with the computers, like as far as the physical objects they are, it's just something I think about a lot. So with that, I'm going to try and code up a 7-segment clock, which is like high school, college project 101. I'm doing it in wowki, which is a tool I've never used before. It, I don't know, it's just like an online simulator thing. So I just have I was just testing it out. I just have some test code to blink this LED. All right. Can I make this bigger? There we go. All right. So instead of this, so I have each, okay, here's the problem. I'm looking at Tata. This is like if you're a hobbyist, this is like DigiKey. Because it just has like a more refined selection of crap and it's just a little bit easier to navigate and their prices are fantastic. In fact, they have the best price in the game on DIN 5 MIDI ports that I'm familiar with. Dude, I would buy their MIDI jacks by the 500, by the 1,000. They'd ship me just like a brick of MIDI jacks, man. All right, so they have these like 4-digit, multi-digit 7-segment displays. The issue is that they're what's referred to as common cathode or common anode. And so the way it works is you basically are expected to hook this up to a multiplexer, which instead of and this is better, honestly, like if you're, by all practical purposes, what a multiplexer does is you just like tell it what digits to turn on, say 730 or whatever, and it'll fire whatever segments need to be fired extremely rapidly. And you might be able to see this if you have like a clock. I have a clock here on my desk that has 7-segment displays in it. If you maybe get out your phone, do slow-mo, or just look in the peripheral of your eye or look at it kind of quickly, you may be able to see that multiplexing happen where it's switching those lights on and off. That is not something we can do because I want each segment to be driven by an LED or by a relay. And I thought, I was like, well, I could just use the multiplexer and then I could just like turn on the relay separately. Like it'd just be kind of two separate outputs. But it's like, no, dude, that's so lame. Like, like you're not just gonna put the relay on there and have it do nothing. Like if the relay is gonna be useless, at least let's at least make good use out of the uselessness. So to get around this, I'm going to design it with individual 7-segment displays, since they can each digit be driven individually. And I'm going to, instead of hooking them up directly, I'm going to actually add, I'm going to add a shift register. Sweet. Okay, how do I do this? And look, they have like the docks and everything. Oh, look at this. Oh, so nice. Wow. Wowki. Wook. I think I spelled it wrong. Wowki. It's not wowki, it's wowki. All right, so what a 7-segment display does. This is my bad habit, is I just comment out my whole thing. And then I just copy my new stuff. I don't know. That's like my poor man's version control. Okay, what a shift register does is it's essentially the same thing as a 7-segment display multiplexer. Like a multiplexer has a shift register in it, because the entire idea is a multiplexer means it multiplies a single input into multiple outputs. And that's effectively what a shift register does as well. It takes three, as far as I know, three data or two. There's a clock pin and a data pin, and so you say like you put the data pin high, and then you pulse the clock, and that's like, okay, that's 1 bit. Then you toggle your data bit, whatever. You pulse the clock again, so you can kind of like, it's dumb. Like it doesn't need a clock. Like you don't. I mean, it has a clock, but it's not timed. It's not synchronous. It's just like, so it'll just sit there and wait. And then I think once it gets filled up, or maybe you send a special bit, then it dumps whatever 8-bit value you just sent off onto its outputs. So I'll show how that works in just a minute here. All right, so it tells me what the pins are. Q0 through Q1, Q7. Okay. Let's look at the code. 2, 3, 4. I have to like manually click each one of these. Shoot. Oh, you can just double click it. Okay, that's sweet. All right, so we want to go. So they got a DS, a clock, and a latch. Maybe the latch is what tells it. Okay. What's DS? Data pin. It goes to 2. SHCP is the clock. That goes to pin 3. I'm just looking at this comment here. Okay, STCP is the latch. That goes to pin 4. The wiring diagram here is going to get super nasty, but that's okay. Now, the common pin on this... Oh, wait, we need to hook up... Can I just, like, hook up a... Is there, like, a... I mean, do I have to power it? I guess I probably do, huh? Where's the ground? Yeah, see, I just want like... Okay. Let's see. Ground. No. Ground. So if I just like stick that there, put that like that. Is that not connected? The heck is going on here? Okay, just hooking up ground. Now this has a pin called common, which these displays are sold at two types: common anode and common cathode. I don't think it really matters. Like you just design for whatever one you have. I don't know why there's a difference. I don't know. That's a good question that I asked myself. So this is saying I should just be able to like hook up a bunch of random digits. So, oh, I need VCC. Dude, this mixtape is really pumping off. All right. So if I hook up, whoops. It's kind of hard to keep the wires straight, so I guess I'm just going to give up. All right. So it's doing something. So the idea is that I would then, instead of hooking the outputs of the shift register directly up to the display, I will hook it up to a relay that connects the display, I guess, between 5 volts and ground. Yeah, okay. I see. So you might want to use a common, what is this? Common cathode? You might want to use a common anode, because then you feed it just one 5 volt line, and then the rest you just have to connect to ground, which just like, I mean, like, especially if you're thinking in terms of like a PCB design, you're going to probably have a ground fill as opposed to like a 5 volt fill. Like you probably won't. So just as far as like routing goes, it might be easier to do that. So maybe I'll switch it. In fact, if I switch this as is, I'll just have to connect the anode to 5 volts, and then it should just invert. So I'll take the common here. Yeah, that's inverted. So that means basically when the Arduino pin goes high, then it removes the voltage potential to ground, turning off the LED. So it just inverts it. Doesn't matter. Okay, so, and you can also like daisy chain shift registers. So what should we do first? I can make it so it displays like a real predictable number. What do I need to do? Predictable number, like actually translate it. How do you actually build a freaking clock? Probably gonna need a real-time clock. There you go. I'm like running out of space here. How does this work? How do you set the time on the clock, dude? Probably have to make buttons. Mechanical key switches, obviously. Is automatically initialized, blah, 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 blah. We have an alarm clock sketch. Wow. I can probably just copy this whole thing. What are they doing here? Let's see, they're using the 7seg library, which I can't use. Alarm tone. What's clock? RTC. Yeah, I could look at that. Well, I'm just gonna go back to mine and I'm gonna start coding up the actual display driver. I don't like zoom. Oh. There we go. Oh, that's cool. Oh, I'll do that. Okay. Let's look at that RTC. Some initialization code to set up the real-time clock, I guess. Interesting. What is RTC now? I could look at the docs or serial.println now. What is it? Oh, okay. No matching function. What did I do? Well, I need to actually hook up the real-time clock. Did they specify or it just has default pins? You give it 5 volts ground and then a weird. Where is it? What pins were they doing? A4 and 5. Which one goes to which? SDA goes to 4. And that one goes 5 is SCL. Okay. Oh, it's like telling me which one to do? Oh. Do I actually have to ground it? Oh, I don't. Okay. Serial.print line now. Okay, it seems like it's working. Now.year. Okay, so what? This is a binary number. So oh, okay. Let's try this. Serial.print. We're cranking Juice OS Liquid D&B Jungle Mix. If you're just joining us. And we're making arduino crap. 33, 44, 5, 5, 6. Okay. So what if we send that off? What if we send now.second? It's definitely doing something. Let's see. This is Glowing Embers, man, by who? What? Glowing Embers. All right. So now let's hook up the display in a way that makes sense. So can I do this? Just to help me visualize it, I can print out the second in binary. Yeah. But what format do I actually need it in? How do I do that? Convert a number to a set to an 7-segment bit or bit. What does ChatGPT have to say about this? Let's ask it. array so 0 equals, what would it be? 0 be where's my A, B, okay. So it would be 0B, 0 would be 0B, A would be 0, B, wait, no, A would be 1, B would be 1, C would be 1, D would be 1, E would be 1, F would be 1, G would be 0, 1 would be 0B, it would just be 0, 0, 0, 0, 0, wait, bottom left. So 0B, A, 0B, A, B, C, D, E, F, G, dot. All right, let's see what GPT comes up with. Oh. It's just going to set a segment map. There's got to be a better way. Oh, the least significant bit. Does it matter though? They were doing something here. Shifted out LSB first. So that means okay, let's do this. How many digits? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we're just going to toggle 1. Oh. Oh. That's because we're not. Pattern. Okay. I don't know why. 1, 2, 3, 4, 5, 6, 7. Am I just... How do I get rid of that? Did I decide that I don't actually... Yeah, I don't need 5 volts and ground stuff. So let's get rid of those. And that'll make our lives easier. Oh, that's probably part of our reason. Come on. All right. Can you rotate these things? That's fine. All right. So I'm going to give myself plenty of space. 0, 1, 2, 3, 4, 5, 6, 7. 7S. What is 7S? Oh, it's a serial output. 0 through 7. Okay. One, two, three, 4, 5, 6, 7, 8. Okay. And on theirs, they have. Okay, yeah. Okay, so this is saying it wants 0 there. 1. Whoops. I would not want to do that. I want to go like this. Then Q2. Whoops. That's F, G, F, C, D, E. Oh, whoops. I'm going to run out of space here for my wires. 3, 4. Let's see what we can do. Can we move both of these things? Yes. Q4. Come bend that around. D. Okay, E. Okay, so we have G, F, E, D, D, E, G, A, B, C, D, E, F, E, F, G, A, B, C, D, E, F, F, G. Com. Oh, and we want to make this, yeah, we already made it common anthode. C. Well, let's come. Oh, I always do that and it makes it Okay, so now we've got Q7. Goes to A, B, 6, 5, C. Heck yeah. All right. Now DS is 2. Can I change the color of the wire somehow? Let's go from, oh, dang it. Let's go from this side. DS goes to pin 2. SHCP that's to pin 3, and pin 4 goes to STCP. I'm going to come out that way, like that. And yes, it looks kind of crazy. Why doesn't the display turn on? Do I need to actually connect it? Oh, you can just zoom. Can I just like turn that off somehow? Where'd it go? Oh, there we go. Perfect. Okay, so now we have effectively mapped the least significant bit goes to port A. Okay. What if I switch it? To be honest with you, like actual Arduino code takes this long to compile. I do not understand why. Yeah, okay, so that just inverts it. I thought it was called binary coded decimal. What is that? This is like my college. This is like my college entry level. No, that's not it. Decimal to 7 segment. Binary. Dude, yeah, it's just using a freaking lookup table. Okay, well, I mean, at some point, somebody's going to have to set the data, right? Like, is there a more efficient way to do this? segment map. I'm getting this code from ChatGPT. Here it is. All right. How do I get just the first number? I got a bit shifter, right? Get first digit of multi-digit number. What? No, I'm not going to do that. It should just overflow, right? So segment map. You want to send segment. What? Can you do this? Segment map. Oh, now dot second. Let's see what this does. Because, I mean, there's more than 10 seconds, but it should just overflow, I hope. Let's try to switch the order, because that was garbled. Oh, I want to print line. Whoops. Okay, so let's figure this out. The pattern. Let's just send it the pattern again. Oh, you can just hit reload, I think. Okay. So that is A, which is the top segment. Let me just double check here. A. Okay. So let's see. 0. Zero. Okay. I see. Am I really just going to sit here and hand do this? 0B 0 0 0 0 1 1 0 0 0. Whoops. Let's see. A B C D E F G dot 1 1 0 1 1 0 1 0 1 1 1 1 0, 0, 1, 0. If you're following along at home, follow along. Here we go. Let's do the next one together. This is a 4. I'm looking at the segments. The mapping is specified somewhere here. A is the top segment. B is the top right. So it just goes around A, B, C, D, E, F, G. G is the middle, and then DP is the dot. Okay? So A, B, C, D, this goes in a circle. Okay? Clockwise. It's easy. So clockwise. For 4, we go 0, 1, 1, 0, 0, 1, 0, 0. For 5, 1, 0, 1, 1. Let's see. 0, 1, 1, 0. I don't trust myself, so I'm gonna do this one. I'm gonna leave what it was before. I'm gonna see if it actually is different. So for 6, yeah, it's definitely different because we need 0, 0, 1, 1, 1, 1, 1, 0. And that's different. Okay. You ever listen to that? 1, 0, 1, 0, 0, 1, 0, 1, 1. Okay. 7. 1, 1, 1, 0, 0, 0, 0, 0. 8, 1. Oh, all of them. So for the last one. 9. 9 is going to be 1, 1, 1, 0, 0, 1, 1, 0. Yeah, let's try that now. Hopefully we get like numbers now. Well, that's part of our problem. We want to give it segment map. Can I just shift the number? Now dot seconds. Is that what you do? Second. Should change with the time, should be a number. That's not a number, dude. Can't I just shift the number? So even then, though, that's not right. What? Okay, so what if I just send the first one? This pattern, I don't think I need. Oh, I've got it set up differently. Q2, what's Q0 goes to the display point, decimal point. Okay. Here's where we get cool. Wait, did I do that wrong? 0. Okay, let's do this again. Decimal is 0. What pin is that? 7? Okay, hold on. Let's think about this rationally. If I just flip this? I don't know what I'm doing. Well, that's a 3. What? I'm doing... What's the first one? Sheesh. How is that possible? Segment map? Like, what? What the heck? Sending segment map 0. Least significant bit first. Okay. 1 0 0 0 0 1. Let's try that. Oh, I know. I know. We not it. There we go. I had it set up for common the other way. Whatever. So I just needed to flip the bits. Okay. So now if I go now dot seconds, what does that do? I did it wrong. If there's 2 options, I'm going to get the wrong one. Okay. Well, let's just set it up correctly again. Least significant bit first. The least significant... Oh, shoot. Least significant bit. Most significant bit is what? A. Okay. Okay. So, starting from A, 1, 2, 3, 4, 5. Oh wait, but ground turns it on. 1, 2, 3, 4, 5. Okay, wait, 1, 2. Let's see. A, B, C, D, E, F, G, dot. Let's just make sure that renders correctly. Holy cow, it did not. There we go. Okay. All right. So for 1, we're going to go 1, 0, 0. Oh, wait. You have the 1 on that on the right side. So you go 1, 0, 0, 1, 1, 1, 1, 1. For 2, you go 0, 0, 1, 0, 0, 1, 0, 0. For 3, 0, 0, 0, 0, 1, 1, 0, 1. For 4, 1, 0, 0, 1, 1, 0, 0, 1. For 5, 0, 1, 0, 0, 1, 0, 0, 1. 5's a tricky one. 6, 1, 1, 0, 0, 0, 0, 1. Wait, no, 0, 1. For 7, 0, 0, 0, 1, 1, 1, 1, 1. For 8, they're all lit up. 0, 0, 0, 0, 0, 0, 0, 1. And for 9, it's almost the same. 0, 0, 0, 1, 1, 0, 0, 1. What is this going to do now? Yeah, I don't know why it just goes haywire. Maybe this is a single digit number. It's not going to change, but at least maybe it'll help us debug. Yeah, see, now it works fine. And it is Friday. All right, so we have numbers showing through our shift register. I'm going to get another Dr. Pepper. All right. So I'm just going to do this. For I 0, I is less than 10, I plus plus. I don't know why you do plus plus I, but I feel like that's like the cool version. Like my brother taught me that. He's like, "Oh, technically it increments it before you." I'm like, "Okay, I don't care." Well, I guess I do now. Okay, so this should just loop through all the numbers we have. Brick. Oh, do I have to do a... Dude, I don't know how to write C++ code, man. Oh, the decimal came on. For 2? What? I just screwed up. Reset the simulation. Take the blue pill. Babies and gentlemen. Okay. Talk to me about daisy chaining. Can I save this? I have a daisy chain example. Oh, look at that. Yeah, but see, it's going to be multiplexing it. Yeah. I do one at a time. Wow. They're doing that with an AT Tiny, though. That's pretty cool, man. Definitely not the first cat to... So, yeah, how do I daisy chain? What is that again? It's a 74HC95 daisy chain. Okay. But shift out, Arduino shift out daisy chain. Arduino shift out daisy chain. He daisy chained 11 of them? Good night. All right, here I need to go to the bathroom, so I'm gonna just give my code over to ChatGPT. I'm gonna tell it what I want and see what it comes up with. New. Daisy chain another 74 HC95 for another 7 seg digit. Let's see. Oh. What's up, Anonymous Red Cat? Hi. Are you interested in Arduino programming? Okay, I'm trying to daisy chain another another shift register. Oh wait, what? Frick! It didn't work. ChatGPT. Sweet. Do you have a lot of experience with? Hold on. Daisy chain another shift register on. Do you have any experience? Are you a student? What are you interested in learning specifically? Are you just here to watch? I'm happy to answer any questions you might have about it. What? The network connection was lost. Is it? No. Mm. Oh, right. There's this. What is the Q7 not? Serial output. You use a Q7 not. Yeah. Oh, that's all you have to do? Oh, okay. No experience. I just like microelectronics and stuff. My laptop is about to die. No worries, bro. That's cool. At one point, I didn't have any experience either, and technically, with most stuff, I still don't have any experience. But I'm using this wowki, which is pretty freaking sweet. I have to say, dude. It's like you got the full simulator. I used something similar years ago. I can't remember what it was now. I think it was like an Autodesk thing or something, Tinkercad maybe or something like that. But I don't know, dude. I think this is like open source, and man, this is a heck of a lot better than breadboarding. I'll tell you that much. Okay, so all we need to do is Q7S chain multiple. And then how are they writing it out? I'm looking at ChatGPT's code. Oh, you literally just shift it and then you latch it. Oh, dude, it's going to be so sick. Okay. I'm listening to Juice OS Liquid D&B Jungle Mix. That's actually probably one of the bigger pro tips I could give you as a senior engineer is listen to drum and bass while you're working. At least for me, it works. You know what, dude? Can I just copy this whole freaking thing? Let's do it. Oh, dude. Is there any way that I... Oh. Oh, yeah. Heck yeah. Okay. So then to daisy chain, all you do is you stick the Q7S into the data pin, which is that. That's what that says as well. Yeah, Q7 has the DS. That's what I'm going to do. Where's DS? That one? Oof. Nothing like a good daisy chain, man. I just love it. It's just the best because it's like exponentially multiplying the effectiveness of whatever you're doing for like free. Daisy chaining displays, shift registers. Okay, here's a fun fact. The shift register is what's inside of a NES controller. How many buttons, query, how many buttons does an NES controller have? Think about it. Count it up in your head. How many is it? Okay, so now we've got our... Let's see. Okay, how many buttons does a Game Boy Game Boy 2? How many buttons does a Okay. It goes there. Oops. Yeah. An NES controller has 8 buttons because inside of an NES controller there is a shift register. That's the only chip. And the NES is just like it basically sends 8 clock pins, so it reads the 8 buttons one by one, loads them up. I think it does it each frame. Load them up, and then execute, reads them off. All 8 bits go into a register where then Mario, tells you if you jumped or not. So then you ask yourself, okay, how many buttons does a Super Nintendo controller have on it? The answer is 16, right? A, B, start, select. They added 4 more buttons. Oh, so it's 12. It's the same thing as a 12-bit shift register. Yeah. Pretty cool. I don't know. It's just cool. It's like, man, they almost like knew what they were doing or something. Okay. Oh, look at that. So it's cascading them down. So it's like 0, 0, 0. That's rad, dude. Look at that, dude. And that's what I'm saying. We just like hooked up 3 more displays. We get multiplied how much output we're getting out of this with nothing. It's just 4 more chips. It's beautiful. It's got to be a thing of beauty. Okay. How accurate is like what if I don't necessarily want a real-time clock? I just want like Arduino to do something. How accurate is Arduino sleep? I don't necessarily need an RTC, just a reliable way to do something. Oh, timer 1. Heck yeah. Let's use a timer 1 interrupt. Get rid of the real-time clock. Because we don't need it, dude. We don't need it. It's a clock. It's got an AM, PM. It's a freaking counter, bro. Okay. Exit. Let's work on the code now. I don't really want to do that. What does this say? Can I use that here? What does volatile bool flag mean? I'll figure that out. ISR routines fill me with internal dread based on cartilage. Screw that. Well, you what, mate? You what? Yeah, we can keep that. Interrupts. All right, so if I say like int second equals 0, and I say here, I can say if flag equals false, well, let's just do what ChatGPT says. It's gonna work. It's working. You go second plus second. How do I make sure? I'm asking GPT. Okay. Can I do this? Mod 10. Heck yeah. Okay, so we have our seconds. Second and second. Okay, plus second. If I don't know. What does plus do? What does plus plus int I versus I plus plus. Like, why'd they call that language I plus plus C? Yeah, dude. Plus plus second. If second mod 10 second equals 0 minutes plus plus minutes. Okay. Plus plus minutes. Do shift registers maintain output state in between writes? What does that even mean? Oh, they do. But if a pin on it is changing from 1 to 1 time, really? Okay. Cool. I was worried that it would like, because we're gonna be driving these with relay, so it like cannot turn off. It needs to stay on the whole time. Yeah, which it does. Okay. Okay. If second mod 10, what calculator? All right. Well, 61 mod 60. Oh, you can't? How do you do that? Mod calculator. Come on. I should know this. 61, 60, 56. Why am I doing it the hard way? Okay. If minutes is greater than 60, you can't have more than 60 minutes. Minutes equals 0. Hours. I'm going to increment hours. I feel like I've written this code like 100 times. Int. This is like cooking cornbread for a southern woman. This is the nerd's version. Writing a clock. Hours. Oh, we got hours. If hours is greater than 60. Wait, no. Greater than 12. We're going to do 12-hour clock here. Hours equals 0. No, it doesn't go to 0. It goes to 1. Yeah, 1 a.m., right? That's so weird. Okay, I don't need this. Shift out and ensure that it's two numbers. What do you say? Pad with 0 if needed. Okay, so then we're going to latch it and we're going to do this. We're going to say, okay, it's going to go all the way to the right. So first we need to shift out the least significant bit of the data pin. We want to say segment map sub minute mod. Oh, wait. Yeah, minute. Let's just see what this does, huh? And I'll start the minutes. Whoops. Minutes. Yeah, let's give our minutes and hours. Whoops. Where? We're going to start our minutes at 35 is great, and hours will do 11. Okay, it doesn't like that. So if we do minutes is 1 and hours is 2, what happens? Oh, I see. See, now we're overflowed on the minutes. That's very strange. Yes. So we're going to do minutes. I'm just going to keep track of the digits separately, bro. Minutes 1, hours 1. There's probably a better way to do that, but I'm not that smart, you know? You know what I'm saying? Okay. Well, I think we do need minutes too. In minutes. Because I'm going to just do both, okay? Okay. All right. So now we have our hours and our minutes set up. So now let's set up individual numbers. individual digits. How about that? Okay. So we say if hours is greater than 9, hours 1, it's going to be the first digit, I guess. So the farthest left, the most significant. That's how I'll think about it. Hours 1 is going to, well, it's always going to be 1. Hours 2 equals hours. Hours mod 10. Right? 12 mod 10 should be 2, right? Yes. Okay. Else hours 1 equals 0. Hours 2 equals hours. Now that's looking weird to me. Now we're just going to do the same thing for minutes. If minutes is greater than 60. Oh, wait, no. Greater than 9. Minutes. Minutes. 1 equals. It's not always going to be. It's going to be minutes divided by 10. Minutes 2 is going to be equal to minutes mod 10. So if you have like 33 mod 10 should be 3. Yes. 33 divided by 10 is 3. Okay. I'm just going to close these tabs. I'm really loving this because they got the docs. It's excellent. This is an excellent platform. Highly recommend wowki. I've heard of this one time before, but I've never used it. So else minutes 1 equals 0. Minutes 2 equals minutes. Now we should be able to come here and we just go. Yeah, dude, we're just going to shift it out 4 times. Okay, so the first shift is going to be the farthest right one, which is going to be minutes 2, minutes 1, hours 2, and hours 1. Let's see what it does. Oh, shiz. Well. Okay, we're getting closer. Something. Oh, we don't want to do it every. I don't know what's going on. What's second mod 10? Like 9 mod. That's 0. Oh. That's going to be a problem. Why aren't we? Oh, it's outputting 11. Oh, greater than 9. We're getting there, dude. We're getting there. Okay. 11. Oh, that's going to be your problem. 0, 0, 0. So we'll say minutes will be 34 and hours will be 11. What is that going to do? Oh. Well. 38. 11:38. We're getting close, dude. Why is it saying... Oh, the number's all messed up. Whoops. Serial... Oh. Minutes to... Well, that's going to be your problem. Come on, dude. It's like the simple math that I just like struggle with. There we go. It's 11:34. Look at that. Now, if we go second, if we go 58, then we should be able to see this roll over. In fact, we don't need that anymore. I'm not using a real-time clock. We don't need a real-time clock. I'm not going to let anyone make me feel guilty about not using a real-time clock because we don't need one. Yeah, it rolled over. Let's go down to like 50 just so we can see it. Well, maybe you go down to 40. Is it working? Oh. Whoops. If second is greater than 60, there's 60 seconds in a minute. What was I thinking? Okay, now we should see it roll over. Like 10 seconds or something? Yeah. No. Oh, in 20 seconds. Because I set second to 40. Oh, yeah, it worked. Okay, now the only other thing I'd like to do is... I want to light up one of the decimal point places on the second. Because that's why we're waking up every second. I want to have a tick, tick, tick. Okay, so we'll say tick equals false. And it's going to be on the second hours. So I think our 6 is bad. I think I need a... There's 6. Need that top digit on. Top segment, I mean. Okay. Okay, so we have our variable tick. And all I want to do is... Yeah. No. I'm going to binary and it. How do I do this? I'll say tick. What did I say? Tick. I don't think that's the right thing. Tick. No. And 1. Is there a cleaner way to do this? Cleaner inline way to do this. Perfect. All right, so every other second we should get the decimal pointer lit up. Oh, snake. Is that going to work? Okay. Yeah. Oh, that's the wrong one, though. There it is. Okay, I'm liking that. I'm liking that. Yeah, we're using interrupts. So the only other thing I want is some buttons. And there'll probably be one. Can I reuse this code somehow? I could just have one button that calls this continually. I don't get this. I don't get the interrupts. That's why GPT's good though, huh? Yeah, this is pretty sick. I mean, I'm just thinking if I just code up a single button and then it just like calls this interrupt thing. Uh um is there like an Arduino library that'll like I mean, what's like the ideal clock? Like I feel like it's just a button that you press. Sometimes you can hold it down. But even then, like half the time it's a piece of crap. So it's just like one for minute, one for hour. Right? We're listening. We're bumping Juice OS Liquid D&B. Fading out is the track. We could do an AT Tiny on this bad boy. We don't even need an Arduino. I don't know what the pricing is on this stuff anymore, but as far as I know, this will work with pretty much any. I mean, if I need a 3.3 volt microcontroller like a Raspberry Pi or something like that, I might need to like check a level shifter in there, talk to those. But I don't know, it shouldn't be too bad. They might even be toggle. It's TTL, so it's probably toggleable with 3.3 volts without even a level shifter. Yeah, the nano is irrelevant. This is just the code, but I'm designing it while coding it. I don't know. That's how I always do it. All right, so we want a button, dude. Let's just see what ChatGPT comes up with. I feel like it's just going to hallucinate. Add two buttons that, when pressed, will increment either hours or minutes. Let's see what it does. It's using internal pull-ups. That's a pro move. If you have any questions about what I'm talking about or what I'm doing, please just let me know. I'd love to answer them. Except for if I don't know. So what is this doing, huh? What is the Arduino button library? Let's see. This is like a better Arduino IDE than like the actual Arduino IDE. What's like the best Arduino button library? Okay, we'll just use it. I don't care. Examples. Okay, and what does GPT want to do here with... Does it have any constraints with interrupts? Okay, I don't care. All right, let's cook up some buttons here. Oh. There we go. Stop. Push button. Oh, frick. Wait, what? Oh. Oh, that's cool. Bounce. Oh, okay. All right. It's going to add some bouncing. It's going to bounce the button for us. That's useful. Okay. Ground it. You're grounded, buddy. Well, I'll make it black. Oh, yes. I'm getting pro at this. Let's just go digital 5. Und digital 6. And it's hitting. The track is fading out. So good, dude. All right, now what do we do? How do we use this? Begin it. Let's give it better names than that. We'll say, oh. Oh, wow. They're doing like some gnarly. So I guess I can just stick it in here. Is that going to screw up our... Oh, whoops. The light's still blinking. Okay, if button hour press, then we'll say... All right, I'm thinking through here. All right, so it is let's just do the basic. So if button hour is pressed, then we're going to say hours. I'm going to say plus plus hours. I mean, I guess I don't necessarily care if it takes over the clock. How do you do that? So can I read it? Could I say... Wait, is this... Look, so I'll say if it's pressed, we'll say while not button power dot let's see the docs. Because you can read while button hour dot read. What about that, huh? What the heck? Dude, I hate semicolons. Like, they're stupid. C++, eradicate semicolons. Huh. I don't know if I'm doing this right at all. It presses it. But returns the current debounce state. Well, maybe we do this. Oh, yeah. It's 10 million hours. I don't know why it's not breaking it though. Oh. No, yeah, why isn't it broken? If hours is greater than 12, it's just going to reset it every time. Doesn't matter. Then this will go back. Yeah. Ah, cool. Okay. Let me go to the bathroom again. Let's say next step is not make it loop so fast and roll over and also output on the display. So I'm probably going to have to break out the display writing into separate functions and everything. All right, here we go.
Is this how?
That's good, Davey. That's good, just like that. Okay, so next steps are... Yes. That's good, baby. That's good, just like that. Okay, so next steps are... Okay. So we say... I need to not do it so fast. So what I want to do... I'm going to say... Right. I'll say... I'm just going to use global variables because I'm cool like that. So we just say whatever the heck is going on right now, just go ahead and write it. And tick, we just don't even care about it. It takes care of itself. So then here... We'll say print time. Does that work? Seems like it's working to me, but the... Cool. Right on. Okay, so now what we're going to do is... I actually am going to say... Okay, I want to do... I don't even care. Void increment minutes. And what this is going to do is this is going to do plus minutes. But more importantly than that, it's going to roll it over for us. And I also want it to set up these variables. Just like that. And instead of this, I'm going to say increment hours. Okay. Okay. Now let's make our void increment hours. It's the same idea. Plus hours. I guess eventually we'll probably have a 24-hour mode as well. But for now, we'll just leave it like that. Cool. Okay, so we're going to come here. Plus second. Second is greater than 60. Let's see if this still works. That compiled suspiciously fast. Oh, do I need to save? Ah! No, it's not working. Ah. We'll say init bool init. If init. Can you do that? It's 5 o'clock. Oh, maybe that's why. It's not boot. Boot init. If init. 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 Let's try that. Restart the simulation. Oh, what? Oh, can I make it optional? Is that right? 12:35. What? Oh. Maybe something like that. There we go. Okay. So now we have it broken out. So we should be able to now get rid of that. We'll say 250. It's simple. It's going to block everything, but hopefully... Oh, yeah. Okay. Print time, Bubba. Let's see. Oh, yeah, look at that. That's pretty sweet. So now... Oh, come on. I can hold it down. I don't know what it's doing there. What the heck? Increment hours. And what's that going to do? I don't know why it's doing that. Is that going to block the interrupt? Because that's what I want it to do. I could disable interrupts. 1. Was that doing it right? Oh, yeah, it's like... It's hitting it multiple times. Yeah, it's like... No interrupts. Maybe I'll do that. Interrupts. Oh, perfect. I don't know if that's what the problem is. What the heck? My clock is broken. What happened? All I want... I thought that's what this library did for me. I just wanted to be able to hold it down. No, don't check out wowki. No interrupts. Interrupts. What's the matter, Debbie?
The piece is not working.
Try a different game for now. Okay, okay. While can I wait for it while button hour dot toggle? Increment hours. Print. What is it? Print time. Delay 100. What is that going to do? I guess while not toggled. Because then it'll toggle when we... Why does it increment so weird? Does print time? No. Four, five, six, 7, 8. Oh, you know what though? I just realized if it's 0 on the hours, we want to display nothing. Right? Unless it's military time, but or 24-hour, but I don't think we're going to do that. That seems to be working to me though. Look at that. Okay. All right. So now we can do the same thing. Button minutes. Increment. Except for we don't want to roll over. Do we ever want that to roll over? Well, no, I just need to check. Yeah, when I increment it. Yeah, I'm going to add another one. Well, can I just add can I just send it 0? Yeah, I'll just make it. I'll just make another one. Because the way I'm doing it with the array, I think it'll work the best that way. So we want them all off. There might be a better way to do that. Where? Line 30? Oh. Dynamically allocated arrays. Come on. What language do I think I'm writing here? Fool. Oh, yeah, look. That's better. Yeah, yeah. Okay, you can set the time in a reasonable way. All right, here's what I think I'm going to do, though. When the button is pressed, I think I'm going to immediately increment hours, print time, delay 500. Well, you know what? Let's do this. Delay 500 here. Delay. Seems a little bit trickier to me. Let's hit it again. Liquid D&B. I love this song. Fading out. Ah. What's the problem? It's a print time. Yeah. Oh. Nah, see, we can't do that because now it's like immediately going into there. Let's try this. Like, what do I do? While button state. Wait, button read. I want to be able to click it faster. So if I take that out, what happens if you hold it? Yeah, it's like not grid. Well, here you go. No, no. We're going to press it. Ding, 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 ding. But I also want to hold it. Is it still pressed? I don't know. There's probably a better way to do this. I don't know what it is, but we'll figure it out. That's even worse. This has changed. Yeah, I don't know, man. Because I can do this. Ah. What happened? Okay, how about this? While not button power dot released. Ah. Is this what I already had? I just don't want it to go in there immediately. I want to have to wait until it's actually being held. So if you just press it once. Nope. That's exactly. What? Why does it? Yeah, even if I press it, why? Let's ask ChatGPT. I want to immediately increment and then hold. I swear there's a better library than this. Arduino button. I thought it was like simple button. Arduino simple button. I started on GitHub. Let's look at my stars. Ah. There we go. This is what I want. Aha, here we go. Okay. All right. Here's what I'm going to do. Yes. Examples. Long press. Handler. Okay, so we want to detect when a long click has been. So we want to say setup. Okay. Button hour dot begin. Okay, and then we're just gonna set. Okay. Serial print line. What? Long hours. Okay. Is that gonna work? I guess I can get rid of this stuff. Oh, whoops. Okay. And you got to call the button.loop. Okay. Button hour.begin is 5. 6. Button was not. Oh, was it button 2? Oh. Like I said, I don't know C++. Is there not like a loop all? Okay. Okay. Okay, and then how do I know when to break out of it? Okay. Long hours. And then you can, in here, you can say button.is pressed. Still pressed. Let's see. Can you reference itself? Oh, dumb. I've been going too long. Probably need to take a break. It's not still pressed. Is pressed. Oh, okay. Maybe we need a button sleep. Or it's a loop. This is getting a little bit cursed, but maybe it works. Why does it print 2? Oh. Let's try this. Yeah, maybe try that. That's very strange. All right. I think that worked. a delay, and then we loop the button. Yes, that is much better. Okay. Okay, let's go. We'll make the same thing for minutes, I guess. You know, if I'm like always just going to call this, increment minutes. Increment minutes. Print screen. Where is it? Print time. Okay. Whoops. I actually kind of like that we just press and hold. Well, let's see if we can get a single press too. Yeah, what are the events? Set tap handler, okay. Button hour dot set tap handler tap hours. I'm totally screwing up my pluralization. Button minute dot set. Okay. I don't know if I need a tap or a delay. Let's try it. Oh, I don't have that. Works pretty good to me, dude. Yeah, you can tap it once. Perfect. Okay. The minutes or the minutes work. So for minutes, I want the delay to be a lot shorter. Let's see, is that usable? That might be too short. Let's go 250, maybe 200. So for is that going to increment hours? Yeah. Okay. I don't want that to happen. That's looking pretty freaking good though, man. We got the buttons. All right. I don't want it to roll over. Um, bool, roll over, true. If roll reset the simulation. Did that roll over? Yep. Okay, perfect. Just make sure. I'm gonna set the clock to 11:59 and watch the rollover happen. Okay, let's watch it. That did not roll over. 11:60. Are you kidding me? Okay, I guess I don't know how to tell time. Is that gonna roll over now though? After it's 11:60, should go to 12:01. What's happening? It went to 12. Okay. All right, we're getting there. Yeah. Whoops. Okay, so let's make sure. Oh my heck. Oh, there we go. 11:59. Actually, that's a good test too. Can I get over? Yeah. 12:01. And you know, we should probably reset the seconds anytime any of that happens. I don't care. I guess we could add a decimal for AM PM. So if it's it's essentially another rollover from the hours. So when we increment hours, int PM, we'll start out with AM. If that's fine. So anytime we roll it over, just going to invert it. And then we're going to do this on that, but we're going to say PM. We invert it. Okay, it's not on. Oh, now it is. Now it's off. $11, $12. Yeah. AM PM is a weird format, isn't it? We basically invert it every time we hit 12. If hours equals 12, hour PM equals not PM. Is that how you do it? Yep, that is how you do it. All right, and make sure that we roll over on 59, not 60. Okay, that's fine because we did it manually. Perfect. Except for, look at that. Maybe not. That's the thing of beauty, man. I think we have ourselves a functional clock. I can't think of anything else that would need to happen on it. Cool. Well, I think that's the end of the stream because I got all the code written. The only difference is I'm going to chuck a bunch of relays in between all these. There are the buttons. Sweet. Great success. Big fan of this wowki. Send this over to Pacheco. Next up, PCB. All right. Bye-bye.